The next lesson is a combined lesson of lessons 5 and 6, and we are going to be looking at describing the center of a data distribution using the mean. Last week we looked at describing the center of data using the median and mode. We can also describe the data using the mean. Mean can be described as a typical or center of value by evening out the data. We can do this by completing a fair share method. So example 1 says, suppose that Robert asked 5 sixth graders how many pets each had. Their responses were 2, 6, 2, 4, and 1. Robert showed the data with cubes as follows. Note that one student has 1 pet, 2 students have 2 pets, 1 student has 4 pets, and 1 student has 6 pets. So the stacks represent the number of students, and how many cubes are in each stack represents the number of pets. Robert also represented the data set in the following dot plot. So notice we have number of pets here. So in this case, the numbers on the number of line are the number of pets. So 1 student has 1 pet, 2 students have 2 pets, 1 student has 4 pets, and 1 student has 6 pets. So here, the dots equal the students, numbers equal the pets, whereas over here, the stacks, or the number of stacks, I should say, equal the number of people, and the number of blocks equals the pets, or the number of pets. All right, so what we're going to do is we're going to use this fair share method to find the mean. So I'm going to have you start by just drawing a line down the center of your paper so that you can separate the two. In the fair share method with blocks, the way that we do this is we want each stack to have the same number of blocks. So we do this in steps, and the first step is to take one from the highest stack and move it to the lowest stack. When we draw this, the way I would show it is I would go to my largest stack, which is this last one, cross off one, and draw an arrow to the stack I'm going to put it on. So another thing that's a good idea to do is to write the number of blocks in each stack underneath each stack. So there's 1 block here, 2 here, 2 here, 4 here, and 2, 4, 6 here. Now, in my next step, I'm going to show the result of what happens when I do that. So the stack that was 1 gained a block from this stack, and it becomes a stack of 2. Notice they're blocks, but I'm going to do them 2-dimensionally just to make my drawing easier. I should actually give some more space here because I'm going to have taller stacks. So my first row becomes, or my first stack becomes 2 now. These 3 were not touched, so I still have another stack of 2, another stack of 2, a stack of 4. And this last stack, which was 6 originally, lost a block and becomes a stack of 5. Okay, so that's your first step. So you take one from the largest and move it to the smallest. And you're going to continue that process until they all have the same number. So I would go now to the stack of 5, take one off, and move it to any stack of 2. It doesn't matter which one. So the first 2 are going to remain stacks of 2. The third stack will now become a stack of 3 because it gained 1. The stack of 4 stays a stack of 4. The stack of 5 lost 1 and becomes a stack of 4. Okay, so again, take one from one of the highest to one of the lowest. So a 4 over to a 2. I'm going to move up over here because I lost some space at the bottom. I have a stack of 2. This stack of 2 goes up 1 to a stack of 3. And you can connect them if that helps to make it easier for you to draw as well. I have another stack of 3. My stack of 4 lost 1 and became a stack of 3. And then my last stack remains a stack of 4. Okay, and then my last step then is going to be taking one from the largest to the smallest, So the first stack becomes a stack of 3, and they all actually become stacks of 3s at this point. Let's see. Okay, so with the fair share method, meaning I'm doling out equal parts to everybody, that would mean that the mean is 3. So the mean is the number of blocks on each stack, on all stacks, I should say, because they should all be the same number. Okay, so that's how we would find the mean using the fair share method with blocks. We can also do the fair share method using the dot plot. It's the same exact idea, and I can kind of show you how this would work based back over to the blocks. So what we did here is we took one from the highest number and moved it to the lowest number. So in this case, I had one person with 6. I'm going to take that. That stack became 1 less. So the 6 became a 5. So this dot will move over here. And the stack that was 1 got 1 higher and became 2. So this brought another dot over here. Okay, so now if I continuously draw this number line again and again, I have 1 on the 5, 1 on the 4. I now have 3 above the 2. So with the number line, it's just a little different. It still gives you the same result. So in this one, I had 3 2s, a 4, and a 5. 3 2s, a 4, and a 5. But in this case, you're just taking 1 dot from the lowest and moving it up 1, 1 dot from the highest and moving it down 1. Same process, it just looks a little different. So now I would take a dot from the 2 and move it to the 3, a dot from the 5, and move it down 1 to the 4. So my next number line is going to have 2 above the 2, 1 above the 3, because this was now moved over here, and 2 above the 4. Okay, so then once again, take 1 from the high, move it down 1, 1 from the low, move it up 1. Okay, so 1 above the 2. I now have the 1 that was above the 3 originally, 1 that bumps up, and 1 that bumps down, and then 1 above the 4. And then the last step is to take, again, 1 from the low and move it up 1, 1 from the high and move it down 1, and that would mean, and I'm just going to have to squeeze my number line here, 1, 2, 3, 4, 5, 6, and you always want to keep the same numbers on the number line. It's going to put 5 dots above the 3. Okay, so again, the mean is the 3. And you find your mean by the number the dots all end up above. Okay, so the number on the number line is your mean. The number of dots above it was the number of people that you started with. Okay, so that's the fair share method. Okay, so we can use the sum of the deviations to prove our mean is correct. Using the previous example, calculate the sum of the deviations from the mean to prove your mean is correct. So the way that this works out is, well, let me first explain to you what a deviation is. A deviation is taking each number from the set minus the mean. So it's how far each number is from the mean. Okay, so you take the number from the data set and subtract the mean from it. Okay, and then the piece of it that says sum means we're going to add all of our deviations together. So if you look back to the original numbers from the set, we had 1, 2, 2, 4, and 6. So those were the original numbers from the set of data. from each of those numbers in the set, I'm going to subtract what I'm saying the mean is. So minus 3, minus 3, minus 3, minus 3, minus 3. Order does matter here. We are subtracting. So it always has to be the number in the set minus the mean, not opposite that. So when we go to subtract these, you're going to kind of notice that we haven't really subtracted smaller numbers minus larger numbers. So the way that we can do this is I would take the larger of the two numbers and subtract the smaller one. So I would do 3 minus 1, which is 2. Since it's a smaller number minus a larger number, it's going to be a negative 2. Okay, so here I'm going to take the 3 and subtract 2, which is 1, but because we did smaller minus larger, it's a negative 1. Same thing here, 2 minus 3 is a negative 1. Here it's a larger minus a smaller, so that's just straight up subtraction. 4 minus 3 is 1, and 6 minus 3 is 3. Something that's really, really important is if you have a 0 as a data point, you need to do that subtracting. And if you have repeating numbers, you need to do one for each of those numbers. So even though the work is the same for these two, I still have to write both deviations down. So now, since we're looking for the sum of the deviations, that means I'm going to take all of these numbers and add them together. Now, the way that I do this is I organize them with all of my positive deviations either first or last, and the opposite with the negatives. So I'm going to put my positive ones first, and remember I'm adding them all together. When I add in my negatives, I'm going to put them in parentheses, just because if I had a positive and a negative right next to each other, it would look kind of confusing. So I'm just writing them all out like this. Now what I'm going to do is I'm going to combine together all of my positives. So 3 plus 1 makes a positive 4. And I'm going to combine all of my negatives together. So if I have 2, 1, and 1, that makes 4. So all together, I have negative 4. If I'm adding 4 plus a negative 4, I'm adding a number and its opposite. When you add a number and its opposite, you get 0. The mean would be 3 since the sum of the deviations equals 0. Okay, so if your mean is correct, the sum of the deviations is 0. Okay, so that's one way to check to see if you had the correct mean. So you take the numbers in the set, subtract the mean from it. You're going to get positive and negatives. Add all of those numbers together. You should have the same number of positives that you do negative, and if you do, that means that your mean is correct. So the mean is in fact 3.